Greetings and welcome to Education and More's Learn Python 3 Programming at a Snail's Pace. My name is Marcus Gardner and I'll be the instructor for this course. In today's video, we're going to be putting it all together. So everything you've learned in the first 9 lessons, we're going to try to put together into one program. Okay, I think we don't cover continue and break in this one, but pretty much everything else. So hopefully you can see the thought process I go into, how I go about determining what to do, and how to break it up into smaller, manageable chunks. The biggest problem I had when I was an instructor for both math and programming was students would just look at the problem and say, I don't know what to do. You got to write things down. You got to sketch something. You got to, do something with your hands so you can see what's happening. You just can't take a big old, it's like you want to take a 50-mile trip walking and you say, I can't do it. Well, you got to think ahead. Okay. Obviously you're not going to do it in 1 hour. Okay. So you got to plan, maybe the first day you're going to walk, 5 or 10 miles. Okay, you got to stay somewhere. Okay, you got to eat. You got to make sure you have places to go, toilet, whatever. Okay, you got to plan things out. Same thing with math and programming assignments and pretty much everything else that are big projects. Okay, later on when you get into university, you'll have physics problems, projects, chemistry projects, all kinds of other subjects. You're going to have projects. The ability to break an assignment apart into pieces is an extremely important one. Okay? You can't be like these other kids that just say, I don't understand. I give up. Tell me what to do. No. Okay? So it's very important that you see the thought process I'm going through. Okay? I might make a mistake because I'm going to be coding it while I'm talking to you. Okay? And so I'll make a mistake. Now, if you think that instructors should be perfect all the time, like some of these Chinese schools, I remember talking to this professor from the University of Southern California. He said he went to teach here in China. And, he wanted to do it, for fun, to help students. So he goes to this school, during the summer, and he taught. He thought he did great. And he got bad evaluation because they said, every once in a while he made a mistake. They were very critical. They said teachers shouldn't make a mistake. The Chinese teachers here, they recite everything so that they don't make any mistakes. They spend a long time preparing for the classes and they wanted the exact same detail out of American instructors. No matter how well, he was a very top rated professor at the University of Southern California, and he was astonished at how critical the Chinese students were. I tell my students right away, I am going to make mistakes. Okay, I am not going to try to memorize my lesson. Okay, I got much better things to do than try to memorize every single word, every single letter, so that I don't make a mistake. Okay, I'm not a robot. Okay, and neither are you. You're going to make mistakes. Okay, you are not a surgeon. Okay, surgeons, yeah, you don't want them to be making mistakes. Okay, but computer programmers, at least while you're learning, great. Now, if you're in charge of a super important database, for the government or for some big company, you don't want to be, drop table space. Oops. Okay. That would be very bad. Okay. But no, until something is dangerous for your computer, when you start deleting files and stuff like that, which I will warn you in advance, until you get to that point, don't worry about making mistakes. Okay. So I'm going to be blunt. I may make a mistake. Okay. I probably will. Okay. I've already made mistakes. You've already seen those. Okay. I don't try to delete those from the video. Okay. I make mistakes. Everybody makes mistakes. So it doesn't matter how good you are. We are going to make mistakes. Okay. So don't worry about it. All right, so let's get going. So here's a problem, a word problem, okay? I know many students don't like word problems, but generally that's how the assignment is given you. Maybe not in this form, but you're giving paragraphs upon paragraphs of what needs to be done, okay? You're not going to be given formulas. Well, you might have formulas in it, okay? But still, you need to be able to read the instructions and then make up your own formulas, make up your own functions, okay? So, anyway, let's read it. Barney Fife is trying to pick up Otis Campbell, the town drunk in Mayberry. Those are two real characters in one of the old TV shows I used to like. I forgot the name. The Barney, I don't remember, I'm sorry. But it has to do with the sheriff. It's very funny. Barney Fife is a big comedian, okay? He carries a gun and he doesn't have a bullet in it because he shot himself once or whatever. I don't remember. But anyway, if you ever get a chance, search Barney Fife and watch the TV series if you can. But anyway, Barney somehow knows where Otis is at all times. Okay? Otis starts at a random position within a square. Corner -20, -20 to 2020. So we're talking about 1,600 kilometers squared. That might be too big of a range, 1,600 kilometers for walking. But anyway, you can use whatever metric units you want to use or standard units, whatever. But anyway, Barney also starts either at a random position or to user input. I'm going to choose user input. Okay. Now, imagine the points where Otis and Barney are standing are the endpoints of a hypotenuse. Okay. I hope you all remember what a hypotenuse is. Okay. We'll do right triangle. That's the diagonal, the longest side of a right triangle, okay? Actually, two right triangles can be drawn and either is correct, okay? Now, if you're going to go from one spot to the other and you're only going, 4 directions, north, south, west, east, you can either go this way, then up, or up, then this way, right? Well, that's correct. It doesn't make a difference. However, I want you to go in a direction where it will make the area of those right triangles the smallest. But you can only go north, south, west, east. I'll explain that sentence in a minute, but hopefully you can do it. At the same time you are moving, Otis moves in a random direction, 9 different positions. One of those is stationary. In other words, north, northwest, west, southwest, south, southeast, east, northeast. And of course, not moving. Okay? So those are 9 positions he could go. So he can move, that's 8 of those positions, or just stay still. Make sure you say which way he is going. Consider all the different ways that Barney can catch Otis. And code your program so Barney can catch Otis, okay? Tell me how many moves it took to catch Otis. All right. So first off, let me explain this trying to make the triangle area small. So before I explain, I want you to stop the video and I want you to take out a piece of paper and pencil and, choose 2 points. Okay, we're actually going to make a third point, make a right triangle. And you want to move over one position. Doesn't matter if you move over right or move up, if you move up to make the area smallest of the right triangle. So, I want you to see if you can understand that before I explain it. If you can, great. Okay? If you can't, don't worry about it. But what's important here is that you try. Okay? Remember what the formula for an area of a triangle is. Okay? Set up 2 points, or third points, make a right triangle, find out the area, decrease it going this way, find the area, decreasing it going this way, find the area, and choose another 2 points and see if you can figure out a way to determine which way you should go. Okay, I'm going to pause for a couple seconds to give you time to pause the video. Okay, so let me explain. All right, I'm going to be using this tool from Geogebra. I don't know if I'm pronouncing it right or not, but anyway. I'm not very good at it, so it may take me a couple seconds to get this correct, but anyway. So first off, let me draw a line. Find the line here. I just did it a minute ago. There it is. I want a segment. So let's say Otis, or let's just say Barney is here. Oh, let's say Barney is here. And Otis, let's say, is here. Okay. Now, this is the hypotenuse. So there are 2 points that will make this a right triangle. Okay. All right. So one will be this point. Let's go ahead and do that. And let's see. So there's one right triangle. And here is the other right triangle. So there we go. And do it again. All right. Now this one has a length of 10. This one, 2, 4, 6, 8, 10, has a length of 10. I didn't want to do that. So let's do it this way. I'm going to delete that. Hold on. Let's start over. Sorry. Let's see. Select objects. Delete. Select objects. Delete. All right. So let's try this again. Sorry about that. Okay. We're still on line, I think. Maybe not. So let's just select it again. Okay. There we go. There we go. And there we go. Let's just double check it again. 4 and 6 makes 10. And this one is 10 plus 2 is 12. So yes. Okay. Now, hopefully you remember the area of the triangle. Okay. I don't know if I can write a formula on here anywhere. Let's see. I don't know how to do that. But anyway. This has length 12. This has length 10. The area of a triangle is 1/2 the length times the height. Okay, so I'm going to get out a piece of paper here. I'm sorry I don't have... Later on I'm going to try and buy a tablet. But right now I can't do that. So let me... So I have... Let me see here. I'm going to just go ahead and bring this up. All right. So remember, the area of a triangle is equal to 1/2 the length times the width. Okay? So right now we have 1/2 times 10 and 12. It doesn't matter which one's which. Okay? All right, so now I said we're going to go in the direction that will make the area the smallest. Okay, so right now the area is equal to 60, right? 10 times 12 is 120 times 1/2 is 60, okay? Now, let's say we go one space this way, okay? So now that length is going to be, the width rather, is going to be 9. So A is equal to 1/2 9 times 12. Okay. Now I don't want to multiply 1/2 times 9, so I'm going to multiply 1/2 times 12. So that's going to give me 6 times 9 is 54. Okay, so that gives me 54. Now, what if I took 1 away from this side? So this will then be 11. So this will still be 10. And this will be 11. Okay. 1/2 of 10 is 5. 5 times 11 is equal to 55. So we saved ourselves. We made the area smaller when we went this way. Okay. So this one, how does this compare to this one? Well, this is smaller. So my first guess, using only one, that's not good, but at first guess, it seems like take the shorter side and go shorter. Okay. Now, a good way to do this, and it's something we learn in calculus, it's like taking limits. Okay. So I'm going to see what happens if I make this even smaller. Okay. So I am going to move this over to there, and I'm going to move this over to here. Okay, so now we're at a length of 2, a width of 2, a length of 2, yeah, whatever. Depends on how you look at the rectangle, okay? All right, anyway, a length of 2 and a width of 12 or vice versa. I don't know how you're looking at it, but anyway, it doesn't matter. All right, so 2 times 12. So this is going to give me 12. So the area right now is 12. Now, if I subtract 1 from here, that's going to give me A equals 1/2 times 2 times 11. Well, that's going to give me 11. Okay? All right. Now, if I subtract 1 from this way, that's going to give me A equals 1/2 times 1 times 12. And this is going to give me 6. Wow, it cut it in half. Okay? And what happens if I do it again? Well, if I do it again, I'm going to get 1/2 times 0 times 12, which is 0. Okay? Which is infinitely closer, less than the other one, okay? So, it does turn out that whichever side is the shortest, then that's the side you want to decrease. And that will make your triangle area the smallest, okay? So, to solve this, all we had to do was test it. You know, take out a couple triangles and see what happened. Okay? And this told us, I'll be honest, the first thing I was thinking of, hey, we got to get rid of this, the long side. So let's start decreasing it. And so I took out a piece of paper and I said, okay, let's decrease it. Got the area. And then I decreased the small one as it said, oh. And then I thought about the limit case. And I said, oh, duh. Okay? I should have known that. But it's been a long time since I've, put it into practice with programming. So I didn't think of it at first. I made a mistake. All right. But like I said, you have to use pencil and paper. Okay. I would have made a big programming mistake if I had just started coding. I was thinking, hey, got to get rid of that long side. Let's do it first. Okay. So by putting it in paper and pencil, I've made the right choice. Okay. All right. So that's the first part. Let's go back. What else? So that's the important part, making sure you understand how to do that part. Now, hopefully you understand the 9 different positions. 8 are movements, either that way, this. Those are, you can only move 4. And then, of course, Otis, who cuts across grass, but Barney doesn't, can go these ways, diagonally. And, of course, he could just say, I'm going to sit here for a while. I'm tired. Let Barney come to me. Okay? All right. Now, how can they meet? Well, let's go back to the graphing table here. Let's erase everything. Let's see here. Select. I forgot how to do this again. Oh, there we go. Select objects. Okay. So they have to be close. So let's say there. One way they can meet is if Otis moves here and Barney moves here. Okay? Now, let's erase this one. Now let's assume that this is Otis and this is Barney. Another way they can meet is if Otis doesn't move and Barney comes over. I'm sorry, this is linked to 2. We're only doing 1. So let's pretend this says 1 and 2. Okay, anyway. So that's the way they can meet. Okay? There's a third way. Okay? And when I was originally programming the very first time, when I taught this last year, I forgot the third way. Okay? Until I said, hey, something's not right here. And I said, oh, that's what happened. The third way is if Otis moves this direction and Barney moves this direction, so they pass each other. Okay? So obviously, Barney can catch him as he's passing. Okay? So what I'm going to do when I program this is I'm going to make it the half point. Okay? Let's say this is 2:10 and this is actually 3:10. I'm going to say they meet at 2.5:10. Okay? But because meeting the halfway point. Let's see, anything else? Yeah, that's the third point. Okay? So that's actually going to be the hardest part to do. Not that hard. Okay? But anyway, it adds a little extra effort to our side, to our problem. All right? Let's see. What else is there? I think that covers it. Let's see here. We just have to say where we're going. Otis is going to go randomly. All right. So, step by step, make sure you understand the problem. Well, hopefully you understand the problem now. Okay. We're going to stop it right here for right now. What I want you to do, now that you have seen the problem and understood a little bit of it, I would like you to try 2 things. First off, write a function that will create the starting point for Otis and also allow us the starting point for Barney. If you understand that okay, then go ahead and see if you can do the rest of the project. Okay, don't worry if you don't know how. Okay, but just give it a try. Okay, it doesn't hurt to try. See how far you can get. All right. All right. And then we'll continue on the next part. Thank you very much. Have a nice day. Bye-bye.